Okay, so for this lesson, we are going to calculate and find the slope, but we are, instead of using the graph to do it by counting up and down, left and right, we are going to mathematically do it using what we call the slope formula. All right, so in yesterday's notes, we talked about all this stuff. I'll clean this up real quick. So we have what the slope is. It stands for m, the lowercase m, vertical rise over horizontal run, up and down, and we did all this. So here we're going to talk about what these equations mean. Change of y over change of x. Change is subtraction, so we have our y minus y over x minus x. If you can remember that, y's are on the top, x's are on the bottom, and we subtract our y's and put them over the subtracted x values. Now these little sub 1, sub 2, sub 2, sub 1 here, that just means the y from the first ordered pair and the y from the second ordered pair. And it really doesn't matter if you use the first or the second y, but it does matter that whatever y you use for the first one, you have to use that x for the first one on the bottom. And that's going to make sense when we go through and calculate a few of these. All right, so let's kind of review how to find the slope. So I'm going to go ahead and plot these on your graph. So we have negative 2, 1, and 2. So negative 1 on the x and 2 for the y. So we have a dot there. And then we have 0 for the x and 3 for the y, which would be 1, 2, 3, which would be here. So if I was going to draw that line, it would be this. And then if you remember to calculate the slope, it would be the rise over the run. So to go from this point to this point, I go up 1 and to the right 1. So it would be 1 over 1, or just 1 for my slope. All right. So when we are graphing, and if we have a graph, it's a very easy and efficient way to figure out or calculate what the slope is. But sometimes you don't have graph paper. The numbers are going to be really big. The slope is could look kind of weird or funky, or just, it might be more difficult to do. This is the formula for how we would find the slope. So we have the m equals, again, the change in y's over the change in x's. So if we take our y values and subtract them for the top, and our x values and subtract them on the bottom, then we would get our answer for that. So if we look at how we filled this in, fill in your ordered pairs for x's and y's. So you can see here, this is my x, this is my y, this is my x, this is my y, and we call this one the sub 1 if we want, because this is our first ordered pair, this is our second ordered pair. All right, so within here, you can see that I put the 2 in for the first y, minus, and then the 3 in for the second y. For the first x, I put the negative 1, minus, and then 0. When you type those into your calculator, 2 minus 3, that equals negative 1. Negative 1 minus 0 equals negative 1. That equals 1. All right, and we also talked about equivalent fractions, so this negative 1 over negative 1 is the same as 1 over 1. It does not matter what ordered pair you use as your first one and your second one. What matters is whatever one you use for the first. So for example, whatever y I use for the first, I use that x for my first term in the second one. All right. I could have done this same thing, but used this as my first ordered pair. So I could have said 3 minus, and I'm going to put these in parentheses. We talked about substitution in parentheses. So I can say 3 minus 2 over, then I would have, since I used the 3 first, I'm now going to use the 0 first as my x term. So 0 minus, and then negative 1 for my x. All right, so as I do these problems right here, 3 minus 2, I'm going to go ahead and bring out the decimals calculator. So here I can actually just go ahead and type it in as I see it. So I can say, my 3, and then minus parentheses 2, and on the bottom I have my 0, and then minus parentheses negative 1. You can see I get 1 as my answer still. All right, this one would have come out as 1 over 1, so we don't need to change the negative 1 over negative 1 to a positive. And actually, if you just set up your decimal calculator like this, then when you're typing these in, it should do the work for you. All right, so there's basically my y's over here and my x's over here. So as I am inputting these, here's what I would like to see. I would like to see the setup of your equation. So here's how the questions are going to be posed. Find the slope of a line that would pass through the following points using the slope formula. Now again, the slope formula, if you get really good at just writing this down, y minus y over x minus x. Then you just need to know that this is your x, this is your y, this is your x, this is your y. Whatever one you use first, whatever y you use first here determines what x you use first down here. All right, so let's just set it up. I'm going to set up how it's going to look on your calculator. So I'm putting the parentheses in. All right, so we know that these are our x's on the bottom and these are our y's on the top. So let's go ahead and just plug in our numbers. So we have 4 for one of our y's. The other y is going to be 5. Then for the x, I have a 2 and I have a negative 1. Now if you have your decimals calculator set up, all you got to do now is type in those numbers. So 4, 5, 2, and negative 1. And I'm going to put this in a fraction form always. So I hit this button, it gives me negative 1/3. So that would be my slope for a line containing those two. Now if I just quickly go through and graph this, because we know a negative slope should be going downhill, right? From left to right. So let's just plot these points. Let's see here. So I have 2 and 4, so 2, 4, 2, 3, 4. There's 1 point. And then I have negative 1 and 5. 1, 2, 3, 4, 5. That would be there. And we can see that that line has a downward pattern to it, a negative slope. All right, so over here, again, I want to see this part set up. I want to see you guys set up the actual slope formula, and then you can type it in to get your final answer. So we have our y's, and then we have our x's. And always put that minus in between, because just like this one over here, one of the common mistakes I see is students would do 2 and then minus 1 and not minus a negative 1, which totally changes the whole formula. All right, so over here, and again, you can use either y value first, but your y values, so your 9 and your 7, have to go on the top. So I can say 7 minus 9, for example. But if I use 7 first, so for my x's, I have to use that 4. So 4 minus, and then we have our 0. And then you can go ahead, and if you have this calculator, just back that out and put in your terms. So I have 7, I have 9, I have 4, and I have 0. And that gives me negative 1/2. So that's my slope of a line that contains those 2 points. Let's try one more, just for fun since we're here. If I have 5, 4 as one of my points, and I'm going to pick another point, 100, 200. Kind of a big one, right? So this is obviously one we wouldn't plot on a graph and then count up, because that would be a lot of little tick marks. So we're going to go ahead and set it up. So we do our change in our y, so our y minus y over x minus x. Now depending on what I want to use first for my y, maybe I'll use the 4. So 4 minus 200, because those are my 2 y values. And then 5 minus 100. So let's go ahead and see what that comes out to. So I'm going to go to my decimals calculator. I'm backing out my formula. Once you put this formula in once, then it's just changing the numbers around. And typically when we're dealing with slope-intercept form, if I give you 2 points, this is going to be the first step you have to do to writing equations for a line. So let's go ahead and type this in. So we have 4 minus 200, and on the bottom we have 5 minus 100. That gives us 196 over 95. So our slope for this problem would be 196 over 95. So pretty nasty, right? If we wouldn't solve this by graphing, by counting up 196 points and then going over 95 points, but you would be able to find the slope of a line that contains those 2 points.